So paper six, you're going to have 40 marks, and the time they have allotted you is going to be 1 hour. For my school's going kids, they have a good idea about this. Okay, they have attempted these papers at school. So you're having four questions. Okay, out of those four questions, you have to draw a graph. You have to talk about the errors and mistakes and the instruments you're going to use. The main question is going to be question number four. That is the investigation and planning question. So this question depicts your writing skills. Okay, I'll show you some in the class. I'll give you some example solutions of like how to attempt these questions. Okay, one of my students, she's so good in writing these things. Like these are skills. Okay, so my dear students, you have to just think about as if you are performing the experiment, and please don't write vague. Vague in Urdu we can say agram bagram, unshared. Okay, be specific to the point. You're not supposed to just fill out those spaces and write a very descriptive thing. You have to be on point, but you have to cover all the directions they have asked you. Okay, if any of the directions you miss out, you're going to lose marks. Okay, so you can plan out this question. Mhm. You did in chemistry. Chemistry, exactly. You have already taken chemistry paper. So you are very well aware of this. Exactly. That is the investigation question. Exactly. The only difference over here is that in chemistry you are supposed to write a conclusion, but in physics conclusion is not required, but we are required how we are going to use our readings to write the conclusion. So this is the thing. Exactly. So for my chemistry students, question number four is similar for both chemistry and physics. Okay, and for O levels it's for 6 marks, and for IGCSE it's for 7 marks. Okay, so let's start. Okay, so you have to think very wisely. Okay, and you have to think like don't write anything which is out of the topic. Don't try to be very much descriptive. Try to write down what is necessary. Okay, I'll show you some sample how to the format, how to write them, and then we can discuss the questions. The first thing is that you are in the lab or in doing the experiment, you are supposed to make make a comparison or the relation between two of the quantities. Okay, for instance, one of the question that we just did was throwing a ball from a certain height and looking at how big the hole is going to be on sand. Okay, so we have height of the ball versus size of crater on the sand. So we have got two variables over here. One is the one which we one is the variable which we are choosing ourselves, and one is the one which is basically going to change because of that. So who is going to tell me out of these two which is the dependent and which is the independent variable?
Height is independent.
That's great. Okay. So these are the two types of variable we must be knowing. One is independent, okay, because we can change the height ourselves, but the size of the crater is going to be dependent. Okay. So while we're doing the experiment, there are a few things we need to know that some of the variables must not change, and they're called control variables. So control variables are the variables which must be kept constant because to make a fair test between two quantities, the other quantities must remain same. For instance, you are trying to see how much your car consumes petrol and the distance it's covering. So the distance you are covering is basically the distance you are covering is the independent variable, and the petrol that is consumed or the fuel consumed is the dependent variable. What happens if your car is having a leakage in the tank or there are exhaust gases going on? Isn't it? So distance is not the only factor. There are other factors as well. Okay, so make sure that there are no other things which are changing. There must not be any leakage, there must not be exhaust gases or something like that. So you can measure how much the car is consuming fuel as per the distance. So in this example, where you have dropped a ball from a certain height and the size of the crater was dependent on the height of the ball, can you just think out what could be the control variables? The size of the size of the ball, size of the ball. Okay, that could be one of the that no, no.
Assalamualaikum, sir.
Walaikum assalam. That could be one of the variables. Size of the ball, okay, and you can say the type of sand we are using. Type of sand we are using, okay. So, so these could be some of the control variables, okay. So we'll be just going randomly into some questions, okay, and then we'll see what you guys are coming up with. I'll just show you how to write down a few questions, and let's move on. So let's start from winter 23 papers. Okay, a few questions we'll do from O levels and a few questions we'll do from IGCSE because the question before is same of them. Okay, so let's have variety of questions. And my dear students who are taking chemistry with me, I'll tell you later on. Shazin is there in the class today? Has he joined? No. Can anyone just make him attend the class quickly? Okay, he's joining. Okay. Who else is not there? Attendance please quickly. Ayan, are you there? Class is
Yes, sir.
important. Yes, sir. Okay. Ali is there. Zainab is there. Habiba is there. Ziad is there. Saad is there. Omar is there. Abdul Rahim is there. Joshua is there. Okay. Who else is not there? Aman. Aman is not there. Okay, let's start. Because we have just started with current electricity a few days ago. So for the last question, there is no requirement of the printouts. You can do it without the printouts, but for the other questions, just okay. So these are the instructions you are being given. Okay, 40 marks, 1 hour. Okay, 4 questions. All right, and very easy. Now, my dear students, a very common question which is going to happen when you take the printouts and do the measurement. When you're going to take the printouts, these values are not going to be exactly the same because of the alignment that is as per the marking scheme. So you guys have grown enough, you must have senses that the length, how to measure the length. Okay? So you have measured the length, but it's not coming as per the marking scheme. Oh my goodness, because you have taken the printouts and that's not the exact paper. Getting? So some of the people, okay, one of my students problem at school. So the school teachers also must know that these are not to have from the marking scheme. So how can you just consider the child is measured correctly? That's fine. Okay. So for these you must have print out. Yes. The problem over here is that when you'll take the printout and you measure these values, you're not going to have the same value as per the marking scheme because of the alignment of the paper. Okay. So don't be worried about that. Yes, of course. No, no, the sizes are different. Okay. So this is really easy. I would like suggest you guys to just sit and do these papers. Okay. Nothing has to be memorized. Everything will be given to you. Even the formula are different. Okay. They will just give you the formula, how to use that formula. Theta is the temperature. Okay. Theta 0, theta 90. So you can just at time 0 and time 90. So we will practice these questions as well. Okay. So right now we are starting with the last question. So let's go into that. This is question number 4. Okay, something related to current electricity which we have just studied. Sometimes they will ask you to complete the table, to draw the diagram. Okay, and okay, so a student investigates the relationship between the diameter of a wire and electrical resistance. Plan an experiment which enables her to investigate how the diameter of the wire affects the resistance of the wire. Okay. Resistance R is calculated from the equation R equals to V or I, where V is the potential difference and I is the current in the wire. Apparatus includes wires of different known diameters. Okay, so you're going to use the diameters differently because you are going to investigate. So the first thing, my bachas, you're going to do is just highlight this point. What are the two variables? Okay, what are the two variables? Okay.
जी सर.
Mhm. The apparatus available includes wire of known diameters. In your plan, list any additional apparatus need. Complete the figure, explain how to do the experiment, say the key variables, draw a table. You're going to draw a table, okay, but not going to put any random values in the table. Please don't do this. You won't get marks for this. Might be you get a negative marking for this. Explain how to use the readings to reach a conclusion. Okay. So let us first draw. So we are having, my dear students, we are going to have an emitter over here to measure the current. Okay. And you can just, okay, complete this. No other instrument is required. Okay. Because we are not going to change the resistance. We are just going to change the
Sir,
wires.
I have a doubt.
Yes.
So I was doing this one theory question that asked me why voltmeters are like connected parallelly.
Why
So like,
voltmeters are, why voltmeter is connected in parallel?
yeah,
You know why? Because in parallel the voltage remains same. If I connect the voltmeter in series, so the potential difference amongst the component and the one which I have to find the resist the voltage is not going to be the same.
well,
Okay, that's
what about ammeter? Why was it in series?
yeah. So ammeter measures current, and current in series is the same for all the components. That's why it's in series.
Okay,
Got it?
yeah.
Okay. So this is basically the circuit diagram. All right. So so the variables we are going to use is going to be, so you can say independent. Independent variable is going to be the diameter of the wire. Dependent variable is going to be the resistance of the wire. Now, control variable. Uh, no, voltage is going to change because of the resistance. Or you can say the same amount of EMF, same power supply, same power supply. Yeah, power supply, and you meant to say that EMF, EMF of the battery. Okay, great. And at least at least one more or two more. Think about what is the other factor that affects resistance of a wire other than the cross-sectional area. Can anyone tell?
Length. Length.
The length. Yes, the length. Okay, so length must not change as well. We are only going to change the diameters, but not the length. If we change the length as well, so it's going to uh, length of the wire, length of resistance wire.
Okay.
We don't want, okay, the length of the wire to be changed. Okay, the resistance will have the value of resistance. Okay, I know we know that it's because of this formula. So it's inversely proportional to the area and directly proportional to the length. So they have only asked us to change the diameter of the wires. So you are going to take the wires of different diameters, but the length of each wire with different diameter must be same. Okay, so these are the control variables. All right. One more thing. One more thing. One more thing. Wire must be of the same type as well because the value of resistivity will also change. Mhm. Yeah, so wire made up of yeah, exactly. Wire made up of same material. Okay, a copper wire will have a different value of resistivity, and a tungsten wire will have a different value. Okay, so this is the thing. Now we're going to write the procedure. I hope this is clear to you. Okay, for this one, you can just write investigating variables. These are the control variables. Okay, now the procedure. How you're going to do? Connect the wires to the power supply. Emitter in series. Oh no. First of all, we will measure the diameter of the wire. How can we just directly, okay, measure the, the procedure? Hmm. Measure the diameter of resistance wire. Can anyone tell me what's going to be the most appropriate instrument?
Macrometer.
A micrometer. Very good. Okay. Set up the circuit with voltmeter in series in parallel and emitter in series. Oh. Hmm. Have they asked you? ha- Have they asked you to do this? You are performing an experiment. You just have to tell them what you are doing. Why you are doing, you don't need to tell that. Okay? So it's a procedure, okay? You don't need to write any explanations for this. And they have just looked at, they explained briefly how to do the experiment. Okay. Now, once you have put the resistance wire, all right, so the voltmeter and the ammeter have start giving you some values, okay? Read and record the readings from ammeter and voltmeter. Okay. Repeat the experiment using wires of different diameter. So basically, my dear students, we have to find out the value of resistance. So can anyone tell me what are the three columns we are going to make?
Current, voltage, and resistance.
No,
No,
you have missed
you
out
have missed out
diameter.
diameter.
Oh,
Diameter of the wire in millimeters or centimeters, okay? Diameter in millimeter, okay? Current in ampere. Okay, these are the states, these are called the column headings. You must write the unit with them as well. That I'm taking current, but in which unit? Is it in milliamperes or amps? Voltage in volts, okay? And finally, the last column is going to be R. That is going to be equals to V over I in ohms. Is that clear? You just draw this table and there is no need to write down any values into it. Okay. So if you have done, now they're saying explain how to use the reading to reach a conclusion. So you're going to say plot a graph of diameter or resistance wire on x-axis versus resistance and we can do one more thing. We can plot a v versus I graph and the gradient is going to be, but we have to basically, whenever we have to compare between two values, so we are going to plot a graph against them. Okay. So my dear students, what you can predict, is the graph going to be directly proportional or inversely proportional? So it's going to be a graph something like this. Here you have the diameter, okay, and here you have got the resistance. So okay, so it's going to, yeah, so it's going to be something like this. Okay, but you don't draw the graph. Okay, it's not required. Never. You just write this. So they haven't asked you to write down. Exactly. They haven't asked you for any conclusion. For instance, you want to write the conclusion. Okay, so you can just write heading of conclusion that as diameter increases, resistance decreases, because diameter and area are inversely proportional. So as diameter increases, resistance of the wire decreases. So hopefully you'll get a 7 out of 7 if you write something like this. Okay. You can write the headings or you can just use the paragraphs, but you can change the paragraphs. They have just given you these all space, so you have to fully utilize this space. Okay. So you will never ever get a repeated question. Okay, all the questions are different. So just please have an idea. This is to give you an idea how you're going to attempt this question the best way. Okay. Investigating variables, control variables, the procedure, the table. Okay, they have also asked us list any additional apparatus needed. So what they have given you, so you can just write down about the additional apparatus. I just missed out. So additional apparatus is going to be an ammeter and a voltmeter. Okay, ammeter and volt. Please add this as well. Yes, at the beginning, additional apparatus. So the additional apparatus is going to be voltmeter and an ammeter. Okay, so this is going to give you. So I hope this is clear to all of you.
Yes, sir.
Okay,
Yes, sir.
perfect. I'll just quickly recap. Okay, I'll just quickly recap. In this question, you are being asked to determine the relationship between the diameter of the wire and its resistance. Okay, so for this, we have to have an ammeter to measure current and a voltmeter to measure voltage. Ammeter is connected in series with the wire and voltmeter in parallel with the wire. Okay, whatever the instruction they have given you in your plan, list any additional apparatus. So in the diagram, they haven't shown us any ammeter or voltmeter, so I have just jotted down. Number one. Number two, you have to write down what is an independent and what is the dependent variable. So as I change the diameter of the wire, the resistance is going to change. So diameter is going to be independent and the resistance of the wire is going to be dependent. The control variables, the power supply EMF, that is the electromotive force, the voltage must not change from the power supply. In simple words, we must not change the power supply as well. Number two, the length of the resistance wire, and the wire must be made up of different material or the same material. So the only thing we are changing for the wire is their diameter. Measure the diameter of the resistance wire using a micrometer. Set up the circuit with voltmeter and parallel ammeter in series to the resistance wire. Read and record the readings from ammeter and voltmeter. Repeat the experiment using wires of different diameter. Then I have drawn the table, okay, which includes the diameter. For that diameter, what is the value of the voltage? What is the value of the current? And finally, what is the value for the resistance? And the resistance, we are going to use the formula they have given us, that's R equals to V over I. Once we have plotted the table, then we can just draw a graph. Okay, we are not going to draw the graph. They have asked us explain how to use the reading to reach a conclusion. So we are going to plot a graph of the diameter. The independent variable comes on the x-axis and the dependent variable comes on the y-axis. Okay, and if you just want to write this conclusion, you're not being asked to conclude. But if you want, you can. That as the diameter increases, the resistance of the wire decreases. I hope it's clear to all of you. Mhm.
Yes, sir.
Screenshot and have this. Anyone who is not clear, just let me know, please. Yes. No, no. Dependent variable is the one which changes because of the change in independent variable. Yes. All done? Okay, let's move on to the second question. Is this clear to all of you? Can we move on? Okay, let me screenshot this for you.
Let's send it in the group.
Okay, this perfect. I'm gonna let's do a question from O levels, okay? So let's go into their paper and see what they have been asked. For my O level students, Aman and Habiba, beta, what happened that before 2023, the paper format was a bit different. So now you have the same format as IGCSE, okay? Same marks and everything. So we can practice both the papers for the sake of practice, okay? And now the content is almost the same. Okay, for our O-level students, it's paper 4. For IGCSE students, paper 6. Okay, so let's go and see what this question asks us. Oh, okay. So this is a question that includes something related to the lenses. And we just covered lenses and waves a few days earlier. But that has to do nothing. You don't have to memorize anything. Okay. This is something which is like if you have the prior knowledge of the topic, you can easily attempt this question. So a student is using a convex lens and need to determine its focal length. And focal length can be given by the formula U plus V. U is the distance between object and the lens, and V is the distance between the focus of the object and the lens. Okay. So the lamp is connected to a power supply and can be switched on and off as required. Write a plan for the investigation. So what we are going to see, we are basically going to see an accurate value of focal length, how we can use that. So we need to find U, we need to find V. Okay. So let me draw the ray diagram for this first. This is a convex lens. I'm going to put an object over here. Okay, and for instance, here is the lamp, which is illuminating the object. So a ray of light is going to hit the lens. It is going to bend like this. The second ray is going to pass from the center of the lens, and they're going to meet at a point where you will have the image. Exactly. We have done this in class so many times. So now what is u and what is v in this case? So my dear student, this is the center of the lens. The distance between the center of the lens and the object is u, okay? And the distance between the center of the lens and the image is v, okay? So now we need to see how we are going to do this. So in real life, okay, in real life, the experiment is done the way they have showed us. So now it's clear, okay? So u is object distance and v is basically the image distance. Okay, so now what we need to do, we have to figure out what are the values of u and v. That's it. Yeah, so there's nothing like dependent variable over here. Okay, so just look, they haven't even asked us to write down the dependence. So every time the question is not the same. Okay, sometimes it changes. So the lamp is connected to a power supply and can be switched on and off. Write a plan for the experiment. In your plan, you should list any additional apparatus needed. Draw a diagram of the arrangement of the apparatus, labeling u and v. Okay, so draw a diagram of the arrangement of the apparatus, labeling u and v. So you can just draw what I have just drawn over there. Okay, that we have a lens, a card is the object. Okay, and we are going to see the image on the other side of the lens. So that is going to be your. So you can draw the ray diagram as well. Okay, explain briefly how to do the experiment. So what are we going to do? We are basically going to lit the power supply. Okay, and we are going to see this is the lens. Okay, this is the lens, and what we are going to see, the image of this card, the image of the card is going to be seen from the converging lens.
Sir,
Mhm.
after discussion, can you open paper Major 2018, paper 64?
May June, Major 2022,
No, 2018.
2018. Okay, I'm not sure whether the pattern is same or not, but let me check because there were some changes in the syllabus. Okay. So they have asked us to label U and V. Okay, so either you can draw the ray diagram, or you can just. So what we are doing? There is a bench. Okay, there is a bench, and there is a card. So this is going to be the distance between the lens and the card is going to be U, and the distance between you here somewhere you're going to see the image, so you can just write V over there. Okay, I hope you guys can hear me. Yes. They're saying draw a diagram of the alignment of the apparatus labeling U and V. So I think you should draw another one. You should draw a separate diagram. Okay. So they've asked us to draw the diagram of the alignment of the apparatus labeling U and V. You can draw the ray diagram as well. Okay. Like this is the object placed over here, and this is the lens. Okay. This goes like this and this. Over here, you're going to have the image. This is going to be U, and that's going to be V. Okay. Now, how are you going to do the experiment? Because you need to find the value of U and V. So you're going to take a meter rule, and you are going to measure the length of the distance between the card and the lens holder. That's going to be U. Okay. Okay. They haven't shown us the object. This is basically the card is not the object. The card is basically the one on which we're going to see the image. Have they told us what they have told us? We use the distance between an object and the lens, and V is the distance between the focused image of the object and the lens. Okay. It's a convex mirror, convex lens. Okay. And it is placed very near to it. Okay. That's going to be U and V. That's fine. Okay. So, my dear students, the first thing we're going to do here is that we are going to measure the distance of U, and U is going to be the distance of the object from the lens. This is the first thing. Okay. Then what we're going to do to obtain a very sharp image, we can slide the lens a bit far or near to have a very sharp image. All right. Now the image is going to be formed on the other side, so you can just measure that length using a meter rule, and from there you're going to use the formula which is given to you, that is U V over U plus V, and you can just make columns for U and V. Now what you can do, you can place the object at like different, because what I need to see is the focal length of the lens is going to be the same, so you can change the values of U. Okay, so U, whatever the value of U change, you're going to get a value of V accordingly. Okay, so for every set of values of U and V, the value of F is going to be the same because the lens is not changing. Is this clear or not?
Sir, clear, sir.
मुझे समझ में नहीं आया है.
Okay, I'll explain again, no worries. Okay, list any additional apparatus needed. So additional apparatus is going to be No, no, we need a meter rule. It's going to be a meter rule. Okay. And there must be a screen where we are going to see the image. Okay. Isn't it? Hmm. Okay. So these are the two because the image we are going to see is somewhere like over here or here. So where we are going to see the image. So we must have some screen as well. Okay. So you can just draw this figure, the ray diagram, or you can just draw something like this and just have your screen placed on the other side and you can call that to be V. Okay. Now what is the method? Adjust the lamp length and the screen to obtain sharp image of the object on the screen. Okay. Using meter rule, measure distance of object from lens, that's U, and from lens to the image. Okay. Repeat the experiment 5 times to get different values of V. Oh, multiple, the 5 is also good. Okay. Now what is going to be U, V there in centimeters. And you can use the formula that's F equals to UV over U plus V. And that is also in centimeter. Okay. All right. State the steps taken to obtain a shout. So you're not going to draw any graph or something like that. Okay. So you can just say use the formula. Use the formula to obtain the value of F. Now it's clear, I hope. Screenshot. And then we're going to Ziad, what paper was that?
May, June 2018.
Okay. Variant
6-2.
62. Okay. Okay. A student investigating whether distance the toy truck will travel along the horizontal floor before stopping depends on its mass. Okay. So you're going to have variable masses of the toy and okay the distance it's traveling. Okay. So we are going to have ramp. We are going to have blocks to support the ramp as shown, toy truck selection and masses, other standard apparatus for the physics lab. Plan an experiment to investigate whether the distance that the toy truck will travel along horizontal floor before stopping depends on its mass. In your plan, you should explain briefly how to carry out the investigation, state any apparatus that would use, not included in the list above. So the distance, okay, meter rule we need to use, or measuring tape, okay, and okay, say the key variables that you would control. So that the dependent variable is the distance the car travel before stopping, and the independent variable is the mass of the toy truck. Control variables can be the height of the blocks, okay, height of the block, okay, inclination of the ramp, the angle of the ramp, that's also very important, okay. And what else? So you are going to yeah, so to say same ramp, okay. So if you're going to use the same ramp, let it have a friction or not, it does not make any difference, because for every experiment you're going to use the same ramp, okay. So set up so now you can just say that set up the ramp on the blocks, okay. Make sure that the number of blocks are same for every experiment, okay. Take us okay, they haven't told us about the stopwatch. We have to take stopwatch as well, but we don't need a stopwatch. We don't need to have a stopwatch because we don't need to find the speed. We just need to find the distance it's travel, okay. So measure, okay, record the mass. You have to record the mass of the basically a toy car. You have the masses, you're going to put those masses like 20 grams and 40 grams, okay. So record the mass of the toy car and make the toy car move along the ramp. Make sure that the inclination of the ramp is same for every experiment, okay. Then using a measuring tape, measure the distance the car is traveled across the horizontal floor before coming to rest. Repeat the experiments at least 5 times, okay, with different sets of masses, okay. The table you're going to draw is going to be the mass of the toy truck, okay, like 20 grams, 25 grams, 30 grams, and so on, and the distance it says travel, okay. So you're just going to, okay, and then plot a graph, mass on the x-axis and the distance traveled on the y-axis to reach a conclusion. All right, that's it. Ziad, is that clear?
Yes.
Okay, a very good news, mashallah, Omar is going for Umrah. Omar, do remember all of us for your, okay, all of us and your prayers, okay. And a very congratulations for that, okay.
Please
Have a
pray
safe
for me.
journey, okay. All right, I need to go for my prayers, so I think we should stop the class over here.
Sir,
And
you also pay for me, okay?
sorry,
You also pay for me.
he resides in Saudi Arabia, Omar.
Who?
So he's just going to have a drive all the way to Makkah, mashallah. Okay,
Why don't you drive with me?
18 hours drive. Okay, all right, so guys, I need to go for my prayers. See you guys then. I might carry on the class, okay. If you guys want to stay in the meeting, you can. I'll be back in 10 minutes, okay. Omar, you want to leave? Okay, you can go then. I think you guys have an idea of how to attempt the paper, okay. We'll just stop the class over here and I'll assign you the papers, okay, because Umar is going, the class recording will stop as well. Okay, see you guys then for chemistry class. Let's join tomorrow and let's coordinate on the group. Okay, see you then.
Okay.
Assalamu alaikum.
Sir,
Allah Hafiz.